Today we're talking about similar figures and finding their missing dimensions. Something from 7th grade math. Hopefully, even if you didn't go here. It's nice to have a little bit of a review chapter in the midst of learning difficult things. Similar are figures with the same shape, but not necessarily the same size. Corresponding sides are sides that have the same relative position. So if you have a rectangle, both sides on the right are similar sides because they're both on the right. Corresponding angles are angles that have the same relative position. So shapes have the same shape, but they're not necessarily the same size. Now, you can't just look at a couple rectangles and say, well, because they're rectangles, they are similar. Because their corresponding sides have to be similar to each other, which means they all have to simplify to the same ratio. Okay? So, we have rectangles J, K, and L. They are all rectangles, however, they are not all similar because all three of them do not simplify to the same ratio. So, all of the angles of the rectangles have a measure of 90 degrees because that is true of every single rectangle. Okay? Compare the ratios of corresponding sides in the rectangles J, K, and L to see if they are equal. So I'm going to say every numerator is going to be our long side, and every denominator is going to be our short side. Because if we start with 1, we have to have every single one in the same order, meaning the numerator applies to the same and the denominator applies to the same. So J, our long over short, is 10 over 4. K is 5 over 2. And L is 12 over 5. Now we need to simplify these. 5 over 2 simplified. 12 over 5 simplified. 10/4, both even numbers, so they can be divided by 2. And we get 5/2. Now, you notice J and K simplify to 5 over 2, L does not. So, J and K are similar, L is not similar to them. A picture 10 inches tall and 14 inches wide is to be scaled to 1.5 inches tall to be displayed on a web page. How wide should the picture be on the web page for the two pictures to be similar? To find the scale factor, there we go. Divide the known measurement of the scaled picture by the corresponding measurement of the original picture. So, here we go. It says, of the scaled picture is what's going to go on the website. So that's 1.5 inches tall by the corresponding measurement of the original, 10 inches tall. Okay, we're not using the 14 right now because we're trying to just find the scale, and we have to use what we know about the website picture. So we take 1.5 over 10 and we get 0.15. So when we divided 1.5 by 10, we got 0.15. I don't know why they put that right there because that was a little bit confusing. And then you're going to multiply the width of the original picture by the scale factor. So here we have the width. 14 times 0.1015 is 2.1, which for some reason they put there. So the picture should be 2.1 inches wide. We know how tall it is. So we take the known divided by the similar measurement, because they're both tall, and then we multiply that by the width to get what the width should be for the picture. A t-shirt design includes an isosceles triangle with side lengths 4.5 inches, 4.5 inches, and 6 inches. Remember that an isosceles triangle has two sides that are the same length. An advertisement shows an enlarged version of the triangle with two sides that are each 3 feet long. What is the length of the third side of the triangle in the advertisement? So, we know that in the original it was 4.5, in the new it was 3.5. So we're going to put 4.5 over 3, okay? Original over new, okay? So then we need to know the length of the third side. Well, the length of the third side in the original was 6, and we are looking for the new third side. So we're going to find the cross products. We have 4.5 times x, and then 3 times 6. 3 times 6 is 18. And then we solve for x by dividing each side by 4.5, because we have to divide by the coefficient. And that is 18 over 4.5, which really tells us nothing. But if we divide it, we get 4. So the third side of the triangle is 4 feet long. Okay? And you gotta know you possibly have that right, because the third side of the little triangle was longer than the two similar sides, so the third side has to be longer than 3 feet. Alright, do your check it out. So just assume that because they're all three rectangles that they're similar. Make sure that you simplify each one to see if the corresponding parts equal each other. And then do 2 and 3. Follow the examples. It will really help you on those. Story problems I know are no fun, but you got good examples.